I'm going to kick off with a shocker of a statistic here, in case any listeners are wondering why we're talking about this. Global shipping is responsible for 2 to 3% of greenhouse gas emissions annually. Now, that might sound small, but it's actually about the same as Japan or Germany. It's also growing fast. Shipping emissions are projected to rise by up to 250% by 2050 if no action is taken.
Unsurprisingly, action is being taken, or at least thought about. The industry is mobilising to slash its emissions in coming decades, but it's not a nimble industry. This is, in every sense, a big ship to turn around. So the obvious question is, can it be done? Can shipping clean up its act, or not?
Our house is still on fire.
This is Thermopylae. This is Agincourt. We have to rise to this occasion.
The transition isn't going to be easy.
So, just how dirty is shipping? Tristan Smith is an associate professor of University College London and also director of maritime consultancy UMAS.
So shipping is responsible for about a gigaton of CO2 emissions, and it's a growing share of global anthropogenic emissions. Transport is one of the sectors which it's been very difficult to decarbonise, unlike energy, for example, because we have growth in demand, and because the growth in demand for things like trade, global trade of goods around the world as economies develop, has continued apace over the last couple of decades. It grows on average about 3% per annum. So the impacts of the sector at 1 gigaton and growing were basically fundamentally at odds with what we then agreed in the Paris Agreement as temperature goals that we had to avoid exceeding. And we know very clearly now that well below 2 or 1.5 degrees means rapid decarbonisation, getting to zero emissions across all sectors by 2050 at latest.
With that in mind, what's the actual answer to the question? Can shipping clean up its act? I wanted to hear from someone accountable. So here's Joanna Christensen from the Global Maritime Forum, an umbrella body for the shipping industry.
The short answer is yes, absolutely. So there is an overall strategy in place for the sector, an overall target. It is not fully aligned with the Paris Agreement, so it's not a zero target yet, but there are movements within the sector to actually raise the level of ambition of the sector. So one of the elements that's important in this target that's been set for the sector by the IMO is that it's an absolute target. A 50% reduction compared to 2008 levels translates into an approximately 85 to 90% in reduction in carbon intensity of vessels that are operating on international waters. So it is a significant reduction.
Okay, so that's the good news. The industry's got a target set by the IMO, that's the International Maritime Organization, to reduce carbon emissions by 50% by 2050. Some say it's not ambitious enough, others that it's impossible to achieve. But targets and plans are one thing, execution another. This is a complex problem to solve. How would we actually do it? Part of the answer is obviously going to be efficiency. Even after decades of technological development, there's still a surprising amount of juice left to be squeezed from that particular lemon. Enter Cubex, the startup we met a few episodes back that's aiming to use blockchain to cut the amount of spare space ships are carting around the world. Here's the founder, Ahsan Tariq.
There's a lot of room where it can be further optimized to work in its best capacity. Before standardization of containers was done, the big problem was you would have different shapes and sizes of ships and different, shapes and sizes of cargoes, crates, boxes, pellets, loose packing, bags. One ship would unload the entire cargo and it would take 3 other ships to then take that cargo from there onwards because it was not standardized. Everything was not built to fit in like Lego blocks.
So you can imagine what a nightmare that was. Eventually, some bright spark came up with the idea to standardize shipping containers. Every container would, henceforth, be the 20 by 40 foot boxes we're all now so familiar with. So all ships could be designed optimally for the same containers. Now Ahsan is interested in the next step.
And from that point onwards, it became quite easy. But the full container industry was booming by manufacturers, shippers, and everybody. But the LCL, where there's less than container load, where multiple parties consolidate their shipments into one, that's where the big inefficiency was. In the past 40 years, there's not been a single centralized marketplace or one place where you could see how many other people are shipping half-empty container from the same destination to the origin, from the origin to the destination. Maybe both of you are paying the full price where both of your containers are half-empty. It could be merged into one shipment, but it didn't exist.
So guess who wants to do that job? Cubex will, in theory, connect any empty space on a container with any consumer that might need it, whether that might be an individual or a manufacturer who wants to ship a few chairs. They can book space right down to the cubic meter, which should help ships ensure that all their available cargo space gets used. Asan reckons it's a multi-billion-dollar opportunity. And there are other proposals for efficiency gains out there, like adding sails to ships. But hitting the industry's target, and certainly exceeding it, is ultimately going to need a bigger step change, or series of them. I asked Tristan to break down the journey in a bit more detail, and he gave us his off-the-top-of-his-head roadmap, which puts things in perspective. The first thing that strikes you is that whilst the 2050 deadline sounds impossibly far away, it is actually, in the shipping world, urgent.
We have about 3 decades and to get to 2050, and in that time period, we also have the single life of a ship built today. So typically, a ship is on the water and sailing for somewhere between 20 and 30 years. It's not inconceivable that many ships built this year will still be in service in 2050. And a lot of the energy sources that are zero carbon options are not compatible with current fuel storage systems, and they're certainly not compatible with the supply chains through which we currently produce our oil-derived fuels today. So we need to find a way to get the land side to invest in infrastructure and to scale up supplies of zero carbon fuels. First, in this decade, for a bunch of ship owners and operators who are first movers and able to support the development of that infrastructure, even if it's not large volume, but enable the sector to take its first steps into testing the solutions that will be necessary in the 2030s. And then as we go into the 2030s, we need to be in a situation where the landside infrastructure and supply chains are rapidly scaling up to meet the growing demand, and the fleet is rapidly both only building zero carbon ships and the existing fleets are being retrofitted to run on the fuels that become dominant in the 30s.
This all trips off the tongue easily enough, but the scale of it is mind-boggling when you think about the ecosystem that's involved here and the number of things that have to be coordinated. It would be hard enough even if the industry was certain about the technology it needs to move to from fossil fuels. But it's not. There are still a lot of options on the table. That said, there is a favorite.
So there are a number of candidate fuels that exist, but most of them are incredibly expensive to make. And when you look at it from a cost minimization perspective and how to keep global trade moving at the minimum cost, we often end up with ammonia. Today, we have the IEA, IRENA, DNVGL, Lloyd's Register, all of these important sort of thought leaders are all saying the future for shipping is ammonia. And that's an extraordinary progression of groupthink over a very short period of time, and has involved a lot of smaller conversations, but is now emerging. Now, I'm not saying that everyone is now saying, right, it's ammonia, let's just do it, because it's still a hypothesis that needs to be tested over the next few years. We don't have a machinery solution that is mature. We're waiting to see how the engine manufacturers, who've all said they're developing ammonia engines, we're waiting to see how successful they are. The challenge of ammonia is that it's hazardous. It has both a high corrosivity and it's toxic. And so if we do have accidents associated with using ammonia, it will have some severe consequences. And so we need to have worked through in this decade the testing of how we could design very safe storage, very safe supply chains and refueling equipment for ships, and very safe use on board vessels, such that we know that we can move to this fuel that has its own sort of safety challenges without creating accidents and serious implications for ecosystems and populations.
The reality is, the more people you talk to in this field, the more you realize that decarbonizing shipping is not really a technology problem. It's more a problem of coordination.
We have all of the ingredients we need to operate ships on zero carbon energy, but that energy is more expensive than oil. And so we don't have any investment or significant investment flowing into it. We have a nascent hydrogen economy globally. There's been more investment this year in electrolyzers and now blue hydrogen as well, which is hydrogen produced from natural gas, where the carbon emitted in the production of the hydrogen from natural gas is captured. We're moving towards blue and green hydrogen, not just for shipping, but because it's a way to capture renewable energy that you can't use. And it's a way to decarbonise heat, it's a way to decarbonise other modes of transport, it's a way to decarbonise heavy industry. So it has applications, but the basic ingredients of that, the electrolyzer, is a decades-old piece of technology. The basic ingredient of consuming that hydrogen or ammonia on a ship is an internal combustion engine or a fuel cell. Again, these are decades-old pieces of technology. The storage and handling of those, again, decades-old pieces of technology. So there's no doubt that we could make significant improvements to each of the steps of the production of the energy source and its handling and its use on board the vessel. And if we make those improvements, we will make efficiency gains that will reduce the cost of a transition to hydrogen and ammonia. So we need to do a lot of learning by experience of actually putting those existing ingredients into play and running them at volumes, producing thousands of tons of ammonia and seeing what we learn from that process that can optimize it even further.
And this is where the forum comes in. As one of the partners in something called the Getting to Zero Coalition, an alliance that brings together close to 150 companies from maritime, energy, infrastructure, and the finance sector, with key governments and international organizations all aiming to get commercially viable zero-emission vessels operating on deep-sea trade routes by 2030. Emma Scoff Christensen is the forum's shipping emissions lead, and of course is intimately involved.
We have a broad reach into the ecosystems that are required to change or adapt certain mechanisms to ensure this transition. Building zero-emission vessels will require government collaboration, international organization collaboration, private sector. But within the private sector, it's not a challenge that solely lies on the shoulders of the shipping companies or the charterers. It's also a challenge on infrastructure, building out the necessary infrastructure to produce the future fuels. And of course, with all of that is the underlying theme of finance. So I see the World Economic Forum's role here as being that platform together with the Global Maritime Forum, Friends of Ocean Action, and all of the wonderful organizations that work with the coalition to really bring massive awareness to this issue and to ensure the right parties and the right stakeholders from a multitude of sectors meet, break down the barriers, create the understanding needed to go forward and create these roadmaps and frameworks so that we can indeed reduce the emission from shipping by at least, if not more, hopefully 50% by 2050.
One of the interesting things Emma raised about this journey was the implications it could have beyond shipping. There are some countries whose energy economies might be altered radically in a world of decarbonized shipping.
Some of the options out there are hydrogen-based. So that could be, for example, green ammonia. And it's green because the electricity produced comes from solar. So that's kind of your the process and supply chain of those fuels, which of course naturally provides a different opportunity for countries who aren't necessarily right now traditionally part of the big energy landscape to become part of that landscape. Let's say you are a country with big wind or solar capacity. What does your national plan for using that capacity look like in terms of powering the grid for your existing grid for your people, but also producing these fuels and potentially exporting these fuels? So in 10 to 20 years, once these fuels of the future are decided upon and investment has started coming in, which is why we do these use cases, of course, then we might see a big geographical change in the international energy landscape. Some of the very popular work out there is the Morocco case study looking at sailing on solar. So looking at building out the capacity of solar in Morocco and using that for the production of zero emission marine fuels. That's one way and one good example of ensuring participation in the global economy, and a very good case study.
Here's Joanna on the same theme.
So shipping's total fuel consumption is estimated to be around 250 to 300 million tons annually. And that is actually a scale that's big enough to be a catalyst for a broader energy transition and unlocking that market for zero emission fuels. I think the other thing that we're super excited about is that the demand for zero emission fuels derived from renewable energy sources has the potential to drive substantial investment into clean energy projects in developing countries. So it could really change the global energy landscape. There's huge untapped renewable energy potential in Chile, in South Africa, in Mexico, in Indonesia, in Morocco, in many, many other countries. And for them, this can be a business opportunity, an investment opportunity, and they could become future suppliers of zero emission fuels to shipping, but to many other sectors as well.
Okay, so far we've been very preoccupied with the supply side of decarbonising shipping. But shipping is like any other industry. At the end of the day, it's driven by demand. It exists to get you your trainers, your white goods, your bananas, or, in my case, primarily vast amounts of coffee beans. So it makes sense to look at the demand side of the equation. Is there a customer demand for any of this to happen? Bo Serup-Simonsen is the man in charge of the Maersk McKinney Møller Centre for Zero Carbon Shipping, an institution set up specifically to research how to decarbonize the industry.
We're seeing a strong trend now that customers are beginning to request a green supply chain. I can say, for example, that we just heard from a big medical company, Novo Nordisk, that in a few years' time, they're going to request decarbonized operations from their suppliers, whether it's transportation or manufacturing. That is going to be a requirement to be on the list of companies from whom they're going to procure services, And that kind of a trend has been announced by multiple companies, BMW, Hennes & Mauritz, IKEA, large companies that are transporting huge volumes of goods across the globe. And I do believe that when companies on that scale start to request that kind of services in order for their suppliers to be relevant, we are going to see strong developments in the supplier base to be able to accommodate those requests.
None of which is to say, of course, that regulation won't also be needed. This is definitely not a problem that the market is going to solve left to its own devices. As you might expect, a lot of the work Bo's team is doing looks at the policy frameworks that can push things along. Here, too, a lot of the questions are still unanswered.
I think policy and the politics, the politicians and the policy side also need to create confidence that once the technologies and the energy sources are available, there will be policies actually driving this change in shipping, because otherwise it's going to be difficult for companies to invest in the development of new technologies whether it's on land or at sea. There's a multitude of ways this can be designed, and I think traditionally what has worked well for the shipping industry is regulation that is goal-based, so it shouldn't be prescriptive down to a piece of technology or a particular kind of energy, but it should rather be a framework that incentivizes innovation and improvements. Whether it's international or regional regulation is extremely important as well. There's no doubt that we're looking at a global problem. The climate change problem doesn't care about boundaries. So of course we should have global regulation that drives the entire shipping sector with more than 60,000 ships to decarbonize.
As ever, all these conversations come back eventually to money. Estimates of the cost of decarbonising shipping are big. Who pays the cost and how and why are at the core of this Gordian knot. But here's the thing, very little of the cost is actually about the ships. The vast majority of the money that's needed is going to need to be spent on land. Here's Johanna.
Yeah, we've actually had a study done for the Getting to Zero Coalition. It was done by UMass and the Energy Transitions Commission, specifically for the Getting to Zero Coalition, and it sort of spells out the scale of the challenge. So obviously, depending on what production method and what fuel specifically, we did the case study specifically on ammonia, based on ammonia produced via renewable electricity. The cumulative investment needed between 2030 and 2050 to meet the goal set by the IMO, i.e. to have shipping's emissions, amounts to somewhere near $1 to $1.4 trillion. If it's to fully decarbonize, that requires an additional 400 billion over 20 years. So the total would be somewhere between 1.4 and 1.9 trillion. The biggest share of that investment is needed in land-based infrastructure and production facilities for those low carbon fuels or zero carbon fuels. They make up around 85 to 90% of the total. And that includes like the production of the fuels, the land-based storage and bunkering infrastructure needed to supply them to ships. Only the remaining sort of 10, 15% or so are related to the ships themselves. And that's like on board, like new engines, new storage technology, etc. But it's only a fraction of the overall cost that relates to the vessels themselves. So the $1.4 to $1.9 trillion of total investment needed need to be seen in the context of global investments in energy, which in 2018 amounted to 1.8 trillion. So pretty much the same on an annual level. And most of those investments are currently going into fossil fuels. So I think simply looking at, bringing some of those investments into zero carbon energy sources is going to take us quite a ways to making shipping's energy transition possible, but also that of other sectors.
As with so many elements of the response to climate change, effectiveness here can't be divorced from equity. To succeed, the entire global fleet needs to decarbonize. But not all parts of the world that rely on shipping have got the sort of cash Joanna is talking about. Those are big numbers, after all. Take the Pacific Island states, for instance, very much on Emma's mind in her work for the Getting to Zero Coalition.
They're an incredibly important voice. They're at the forefront of being the most affected by the crisis, the rising seas, but also the dependability on mobility between islands, etc. Often you see some of these states also being emerging economies. So there's a big dependency on import and domestic movement and domestic shipping to ensure just movement of products, food security, etc. And so one of the things there is that you're asking countries to decarbonize who already have a lot of, let's say, challenges on their plate. How can that be done?
How indeed. This is Peter Natal of the Pacific Blues Shipping Partnership, an initiative aimed at financing the transition to low-carbon shipping in the Pacific Island states. which are on the very front line of the effects of climate change and, of course, very dependent on shipping. He reckons they need about $500 million in grants, loans, and blended finance to make the Pacific part of this revolution.
Like 63% of shipping emissions comes from a small group of ships. It comes from large container ships, bulkers, and tankers, see? And that's the vast majority of the emissions that we have out there. So everybody's focused on these large ships. The point that people miss is that around about 25% of world emissions from shipping come from ships under 10,000 tonne. They only move 4% of world cargo, but they're servicing more than half the world's population. It just happens to be the poor part of the population, and therefore it doesn't get a lot of traction. We are not represented at IMO. We don't have any ability to bring the vast majority of countries into the global discussion at the moment on decarbonisation. It is almost entirely dominated by large and developing economies and by large industry players. And so we see an opportunity, or the only opportunity for transitioning Pacific domestic, which is by and large a shocking situation. I think the last ship imported into Fiji was north of 3,000 tonnes and over 60 years old, bought for scrap, and then we try and milk a few years out of it. We have the longest transport routes in the world. We have the thinnest economies in the world. All our routes are blue water. We have to maintain domestic shipping if we want connectivity. It's our equivalent of roads, highways, bridges, fast rail, all those things. We use ships. We're islands. If we can't connect our people, we don't have economies, we don't have cultures, we don't have anything else. So shipping is our absolute lifeline. Climate financing and a decarbonisation strategy allows us a unique opportunity to transition to better quality ships. We want those ships to be green, but we want them to be better than what we've got. And better means more appropriate, more affordable, and all of those sorts of things. Our plea to the forum is, yes, let's get to zero. Let's all get to zero. Leave none behind. And that's the challenge to the industry, really.
Peter is worried that without support, Pacific states will end up with worse access to the alternative fuels and technologies that the global industry is rushing towards, even though the climate change threat is more immediate and existential for them than for anywhere else on Earth.
So we need international shipping to decarbonise immediately. However, the measures being adopted by large international shipping to decarbonise are detrimental to our ability to decarbonise or to get the benefit from that decarbonisation here in the Pacific. It's a conundrum that we're often faced with. We're the canary in the world's cage at the moment. There's a lot of science around at the moment that is saying that we've already missed the bus and that a 1.5 degree target threshold is unachievable. We're past that. We're probably past 2 degrees as well. The issue for us is that 1.5 degrees, of course, only gives us a 50-50 chance of survival. Yeah. So 1.5 degrees gives us a 50-50 chance of living on death row or being executed. It's pretty much that simple for us. Yeah. So we're the canary in the cage. As long as we're singing, the world knows we're still alive. Once we stop singing, the world will have entered into a new and very, very dangerous phase. We will have started to lose countries. This is something the world has never done before. We've created new countries, East Timor, classic example here in the Pacific. We've never actually physically been that, stupid, absent-minded, short-sighted, that we've actually lost entire countries. But we're about to do that. 4,000-year-old civilizations are about to go extinct. Yeah, serious issue for us. So we're very interested in this international debate. We're interested to see if shipping can continue to be a profitable enterprise, the global trade can continue, and all these sorts of things, and the climate crisis can be averted.
So, is it going to happen? Make no mistake, it's not a soft target for the shipping industry to get clean. It's going to take a mammoth effort of political leadership and coordination sustained over decades, plus trillions of dollars. And yet, there isn't really an alternative. And if the conversations we've had are anything to go by, It just might happen. All right, that's it for this week and for this series. I really hope you've enjoyed listening and taking some inspiration from the stories we've aired. Please do comment or get in touch and let us know what you've enjoyed or not. And with any luck, we'll be back for another series in the near future. In the meantime, why not check out some of our sister podcasts? Until next time, farewell.